Okay, we're continuing with problems from Holiday and Resnick, Chapter 9. And this is problem 55. A 5.0 kilogram block with a speed of 3 meters per second collide with a 10 kilogram block that has a speed of 2.0 meters per second in the same direction. After the collision, the 10 kilogram block travels in the original direction with a speed of 2.5 meters per second. What is the velocity of the 5 kilogram block immediately after the collision? By how much does the total kinetic energy of the system of the two blocks changes because of the collision? Suppose instead that the 10 kilogram block ends up with a speed of 4 meters per second. What then is the change in the total kinetic energy? Account for the results you obtain in C. So we need to make a sketch of this. We have a 5 kilogram block. And it's moving at a speed of 3.0 meters per second. That's its initial. Then it collides with a 10 kilogram block that has an initial speed of 2.0 meters per second. Then after the collision, the 10 kilogram block travels in the original direction with a speed of 2.5 meters per second. And we want the speed of the 5 kilogram block. So we start off P initial is equal to P final. Let's just clear our thoughts a little. So we have 5 kg times 3.0 meters per second plus 10 kg times 2.0 meters per second is equal to 10 kg times 2.5 meters per second plus 5 kg times VF. That's what we're looking for. So it looks like we got everything we need just to solve this problem. So we can say VF 5 kg VF is going to equal to 5 kg times 3.0 meters per second plus 10 kg times 2.0 meters per second. And we'll take this on the other side, minus 10 kg times 2.5 meters per second. And we'll divide through by this 5. We just do this and divide through by this 5 kg. So the kilograms will cancel. We got 15 meters per second plus 20 meters per second minus 25 meters per second. All that's divided by 5. And this is going to equal when we finish, this is going to be 10 meters per second divided by 5, which is going to be 2 meters per second. That's part A. Okay, part B asks, by how much does the total kinetic energy of the system of two blocks change because of the collision? Well, so the change in kinetic energy is going to equal kinetic energy final minus the kinetic energy initial. So what is the kinetic energy final? Well, that's going to be 10 1/2. Remember this 1/2 mv squared. So 1/2 times 10 kilograms times the velocity square plus 1/2 5 kg times the velocity square, which we just computed, minus the initial, which is 5 1/2 minus 1/2 5 kg 3.0 meters per second square minus this 10 gauge 1/2 10 kg 2 meters per second square. Okay, this is going to give us this is going to give us 31.25 plus 4 10 minus 9 times 2.5 minus 5 times 4, which is 20. Okay, let's just calculate this out real quick. which is a negative 1.25 joules, which is approximately equal to a negative 1.3 joules. Part C. Suppose instead that the 10 kilogram block ends up with a speed of 4.0 meters per second. What then is the change in the total kinetic energy? Well, we don't need to completely remake the wheel. We're saying right here, rather than have a 2.5 meters per second, it ends up with 4 meters per second. So if that becomes 4 meters per second, then that would be 10 times 4, which would be 40. So the change in kinetic energy, if that would happen, would be just, let's just put it down here, would have 10 kg times 4, it's part C, which equals, okay, that's plus 40 joules. All we did is put 4 meters per second here, multiplied by the 10. So C, it'd be a change of plus 40 joules. Now, for the last part, D, account for the results you obtain in C. Well, since we got an increase in plus 40 joules, that would happen in a situation, say if you had two of your little lab cars and you had a loaded spring in here, and when they bump, the spring would come out and give it a little more kinetic energy, potential energy from the spring turned into kinetic energy. That could happen with when you bump with something that's spring loaded, or some kind of explosion that would propel them apart. So that's where the extra kinetic energy could have came from.